Okay, so for question 1, you need to graph by making a table with at least 5 points. And then your graph just has to span that given grid. I am going to give you a straight edge on your quiz, so you'll be able to use that as well. And then you can have any 5 points. They do not have to be the same ones that I have. I showed my work so you can see how to plug it into the original equation and get your points here, like you plug it in, but you don't have to show that work to get full credit. Okay, you can also use some of the strategies we talked about where you can start at your y-intercept if you put it in this form and go up 3 over 1, up 3, right 1, down 3, left 1. You could do that and then put the points in using that method. Okay, but you have to have a table with at least 5 points to get everything for question 1. For question 2, you are graphing using the x and y intercepts. I was a little surprised that some of us forgot how to do this. Remember, with an x-intercept, you want to plug in y is 0. Once you plug it in, you're going to get to negative 6x equals 18. Now, I put a little star by that step, saying that's one of the integral steps. You have to make sure you have that, and you have to make sure that you have x equals negative 3. You can also write it as a point. Just make sure if you're writing it as a point, you're writing it correctly. The 0 is going to go in for the y. Okay, for the y-intercept, you can plug in x is 0 and solve. Again, I put a little star next to the steps that you have to have in order to get full credit, because a lot of us are going to know, okay, when you plug in 0, it's just 3y equals 18. So I just want to see how you're solving to get this final value. And you have to identify what your x and your y are. Okay, so you're solving for x here, you're solving for y here, and then we're going to plot those 2 points, connect them with a straight edge. I had some people for the y-intercept, instead of using this method, they put this in y equals mx plus b form and found the b value. That is fine. Okay, but you do have to make sure you're identifying both of those there. Okay, any questions on 1 and 2, graphing those lines? Okay, for number 3, you're going to graph each inequality, and then you have to use a test point and show your work. So this is something we talked about on our homework as well, making sure that you have that. Okay, and some of my work, I'm going to have more than what you need because I'm explaining it to you. I think it's helpful to identify and write out right away whether it's dashed or solid, okay, because it's easy to forget that it's dashed when we're so used to graphing solid lines. And then we're going to start at the y-intercept and then use our slope to find our other points. Okay, so I explained that in my work as well. You don't have to have that. You can just do it. Okay, what you do have to have is your test point. So you got to tell me what your test point is. So 0, 0 is the simplest one to use because when you plug in 0, right, this is going to be 0 plus 2. And then I need some indication on whether this is true or false. I'm okay if you put a check for true, or if you write true. If it was false, you put a slash through it, and you could write false. Okay, but you do need to make it clear if it is true or false, and have a simplified inequality there. Okay, and then based on if this is true or false, if it's true, you're going to shade where the point is. If it's false, you shade where it is not. All right, and then let's look at part B. So part B has the same directions there. Okay, so this one was a little bit trickier because when you were solving to put it in the form y equals mx plus b, you had to divide by a negative. So what happens when you're dividing by a negative? Good. Okay, so your sign's going to flip. So if y is greater than 1/2 x minus 2. So when you're graphing, you're going to start at that negative 2. You go up 1, and then right 2. Up 1, right 2. And then if you want to reverse it, down 1, left 2. Okay? Now there's 2 ways you can do your check-in. So I wrote both of them. You only have to write one of them. You can either plug 0, 0 into the original equation, which is what we have here, And if you do that, you get 0 is less than 12, which is true. Okay, or if you plugged it in here, okay, then you're going to get 0 is greater than -2, which is also true. Okay, so if you need to make an adjustment because you forgot to put the sign, I would just write a little note on there. Okay, and another good thing too, like if you want to verify that you did this correctly, you should get the same like shaded region. So if you were to plug in 0, 0, and you got true here and then false there, then you know that you didn't solve it correctly. That could help you troubleshoot. All right, now look at the directions here. I've highlighted them for us. It says graph the piecewise function. You must include a table. That means part of my rubric for grading this question is that you have a table there. Okay? Yep. Okay, and then you state the domain and range and set builder notation. All right, so for this one, x is less than or equal to -3. So we're going to start at -3, and then I just went down -4, -5 because it's less than. I always like to start at my key values. If you guys want to do -5, -4, then -3, you can. I also like to put what type of circle it is there. You don't have to have that. I like it so I'm not like looking back and forth a bunch of different places. I like to look at this, see what it is, and then put it on my graph. Okay, and then y or x is greater than -1. So yesterday we reminded ourselves, even if it's not an equal to, okay, we have to include it because it's going to go right up to that point, and we're going to put an open circle there. Okay, so an open circle at -1, -6. Now this is like on the 6, so I know that's kind of hard to see. Okay, but I want you to remember that even if this is an open circle, do I have any other open circles here? No, right? No, they're all just points. So if they're just a point, it's a closed circle. So there should only be one open circle at this key value. Okay? All right, let's talk domain and range, our favorite. So when you are looking at the domain, you are looking from left to right. So if this is going off to -infinity, okay, I'm going to look and see where it goes to on my x, -3. So this segment here is just going to be x is less than or equal to -3. And then I have a small gap here where I don't have any line. It picks back up at -1, okay, and then it goes all the way to infinity. So that's just going to be x is greater than -1. No equal to here because it's an open circle. Okay, equal to here because it's a closed circle. For the range, now I'm looking up and down. So I'm going to start with the lowest value. So my lowest value is -6. So it's y equals -6, and then there's a gap here, and then it goes from 6 to infinity. So it's y is greater than or equal to 6. Okay, I know that the textbook uses f of x instead of y, and you are welcome to do that. It's just y is a little bit less writing, looks a little cleaner, so it's better than all these f of x's. But you can do either one, okay? All right, what questions do we have on 4A? A few slides. All right, let's look at 4B. Okay, so for 4B, we have 3 different tables. So the first one for 3 is a constant. I'm fine if your table even just includes the -4, 3 there because it's a horizontal line. And then just remember this is going down, so -5, -6. Again, I like to put that this is a closed circle here. And then for these two key values, you have open circles. So we're putting -1 and 1, zeros in the middle. We're plugging that in, and I also like to write this on the top. In fact, when I was writing this out for you, I wrote f of x equals f of x equals f of x equals. That's how we did it in our notes. Okay, so you have those three separate equations. The last one is a constant as well. We have an open circle here. Okay, so I have -4, 3, and that arrow is going to the left. I have an open circle at -1, 3, and at 1, -3. 0, 0 is not an open circle. Okay, so fix that if you need to. And then at 3, -4 is an open circle, and then that is going to the right. Remember that we're always going from the lowest value to the highest value. So for the domain, we're going to start, it's a -infinity to -4, so that's x is less than or equal to -4, or -1 to 1. We have open circles, so no equal to, or x is greater than 3. Okay, for both of these examples, you ended up using the same things you had here because there were no overlaps. But sometimes things are going to overlap, either in the domain or the range, and we have to combine a few things together. So let's look at the range for this. The lowest value is -4, so I'm going to put y equals -4 first. Then there's a little gap here. It goes from -3 to 3, okay, but see how these overlap here? So this is an open circle, but this is a closed circle. So the closed circle is going to take precedence. So it's going to be -3 is less than y, and that is less than or equal to 3. Okay, so if you put -3 is less than y, which is less than 3, or y equals 3, okay, if you have y equals 3, you're just going to include it here. Those are not going to be separate. Because they overlap at 3 on y, you're going to combine it. Okay, so if you have that extra one, you're just going to make it equal to. Okay, and feel free to write that down. All right, for number 5, you guys had to write a piecewise defined function. So the first one is 14.99x if, and then this is the only one I'll accept 2 answers for because we talked about this. It can either include 0 because technically you can buy 0 pounds, right? Or it doesn't really make sense that you're going by nothing, but you could. So if you just put less than, I'm okay with that too. Yeah, you wouldn't want to go in and say 0. But again, you could do that and it would cost nothing, so that would work. But you do want that because you aren't going to buy any negative pounds, so you do want to start with 0. I would accept less than or equal to x or less than x. And then it's just a less than 1 because it's fewer than a pound. It says 1 to 3 pounds, so that's where you include the 1. Okay, and then it's 13x, and then $9.99 x if x is greater than 3. Okay, and I think I forgot to tell you that on your review that you could use this to find your answers. So $32.50 for 2.5, and then f of 6 was $59.94. Okay, when you're doing this on your test, I'm going to have nicer values. So instead of $14.99, I would have 15. Okay, so you would do that without your calculator. So 15 times 2.5. Okay, let's do that in our head. So we do 15 times 2, which is 30. And then what's half of 15? 7.5. So then it would be $37.50. Okay, and then if it was like instead of $9.99, I would have $10, right? So 6 pounds at $10 would be 60. Okay, so don't worry, I'm not going to make you do those decimals without your calculator there. Okay. Yeah, so it'll be nicer numbers there. All right, let's look at our absolute value. So it says, again, you have to make a table of 5 values. Your table should look like my table, and then you're going to save the domain and range in set builder notation. Okay, so the way that you find the center is you can take what's inside the absolute value and solve for x. Then you can plug it back in to find y. That's your vertex. But since we've learned how to do this, I've also talked to you about the vertex form. So you can also just look at this and pick out your h and k, right? So if you look at this and pick out your h and k, you can put 5, 1 in the middle, and then we're just going 2 to the right side and then 2 to the left side, and then we're plugging those in to find our values. I wrote out my work down here for what I was plugging in. Okay, you can do that in your head if you would like to, or you can write it out. I find that I make less mistakes when I write that out, so when I'm doing a test, I like to write it. Okay, and then again, you'll have the straight edge so that you can span your grid. Okay, your domain is all real numbers. Your domain is always all real numbers for the absolute value. So I'm really hoping those are some easy points you can pick up, right? All real numbers, that's your domain. The range depends on the way the graph is going. So all of these points are below 1. So we would write y is less than or equal to 1. Okay, the points go from 1 to negative infinity, so it's going to be less than 1. And then for B, again, you can take what's inside and then you can set that equal to 0 and solve. Okay, you can also see what your h and k are, which in this case, there's nothing added or subtracted to the x or to the outside, which means it's 0, 0. And then once you find the center, we're just going 2 to the right, 2 to the left, and we're plugging those back in. Make sure when you plug it in, these should be symmetric. Okay, so if they're not symmetric, then that should let you know you didn't find the center or you're plugging something in incorrectly. And then again, it's all real numbers for your domain. Your range, all of your points are above 0, so y is greater than or equal to 0. All right, the reflections and all the transformation. We're going to describe each transformation as it relates to the graph of the parent function, and you have to use key terms. So when you see those directions on the test, what does that mean? That means you have to identify your parent function and the transformation. And then I've listed all the transformations you have to know. So if it's a reflection, you have to know whether it's over x or y. If it's a translation, that I didn't write down, but that's up, down, left, or right. Okay, the translation. And then the horizontal or the vertical stretch or compression. Okay, so we learned all of that in 1-7. Okay, so for the first one, it's f of x equals x squared. It's translated 5 units left and 2 units up. Those are both translations, so you only need to say translated once. Okay, and again, the order that you put that in doesn't matter. You can say left 5 units and up 2 units. You can say 2 units up and then 5 units left. That's fine. But check that you have your equation, the type of transformation, which is a translation, and then where it's going and how many units it's going. Okay, I like to do my annotation. Again, it's because I'm teaching you this, so I like you to see, okay, if it's inside, I know I'm going to the left if it's positive. That's what I'm writing out. I also sometimes will write out the vertex so I can see the negative, and that reminds me that it's left. Okay, and then you can see I have a lot of annotations here. So you have y equals the absolute value of x. It's reflected over the x-axis. I know that because of this negative. You don't have to do that on your test. I'm just telling you, as I'm studying things like this, it helps me to circle and say what is leading to each transformation. Okay, and you can say over, or you can say across, or you can say in, over, across, or in the x-axis, and then it's vertically stretched, or you can say stretched vertically, and translated 1 unit right. Okay, I said that you could say like what it's stretched by. You can say by 3, but just be careful because horizontally it's a little bit different. And it's going to be vertical because this is outside of that absolute value, which means it's vertical. And because it's greater than 1, it's a stretch. And then the vertical and the horizontal rules are switched. So this one is y equals x squared is reflected over the y-axis because your negative is inside the parentheses. It's stretched horizontally, and you can see I wrote down it's inside, so it's horizontal. 0 is less than 1/3, which is less than 1. That is a stretch. So if you're telling me what the factor is, remember you do the reciprocal. So stretched horizontally by 3, not 1/3. Okay, and then it's translated down 1 unit. Okay, and again, you don't need any of those annotations on your test to get full credit. That's just to help you understand where those come from. Okay, so we know how we're creating those. All right, what questions do we have on that?
So how do you know when to include like the horizontal stretch?
So anytime you have a factor on the outside, a constant term, that's going to be something vertically stretched or compressed. And then anytime there's a number on x, either inside parentheses, which you can see on yours that you have your parentheses here, inside parentheses here. See how there's nothing in front of the x? That's how I know I don't have it for this. Okay, but this one's on the outside and this one will be on the inside. And it's multiplied instead of added or subtracted. Okay, on the back page, you're writing an equation. I said work has to be shown for parts B and C, and we'll talk about that. So I even have work for part A. You don't have to have all of that. You are going to find your vertex, your H and K. So -5, -4. You're going to plug in for H, the -5. For K, you're going to plug in the -4. To find your A value, you do the rise over the run. So this is up 1 over 1. And then it opens up if your A value is positive. Okay, again, I showed a lot of things here. You don't necessarily have to show those. You might want to write out your rise over run. What you do have to show your work for is part B. So we went over this again the other day. What you have to show is that you're plugging in your vertex. So your vertex is -3, -4. And then you pick any point on the parabola. I chose -2, -2, and plug that in for x and y. And then you have to follow your order of operations. So inside the parentheses, I got 1. 1 to the second power is just 1. And then I can move over my 4. You could use -4, -2. I think some people even use, was it -1, 7? Was another point, or not 7? Was there another point that you guys used on there? -1, 4. Okay, and then again, you would get A. So I need to see what you're solving for there. Okay? And then for C, you do have your rise over your run. So your work can be as simple as showing like your slope, right, is 2. And then if it's going down, it will be a -2. Okay, so there's like very minimal work to show for that. Okay, B is the main one I want to see your work for. I also showed you on C, you could solve this like we did for B by finding a point on there, plugging it in, and solving for A. So if you're ever unsure about your slope, okay, you can use the algebraic method to solve. All right.